I'm going to walk you through the post-processing phase of keyword spotting. Now, if you remember, the post-processing phase comes right after the inference stage, and it's got two major components. The first stage is the command recognizer, and the second stage is the command responder. As a quick recap, the command recognizer's job is to make sure that it's detecting the right keyword. In other words, let's say if the word is up, then it's got to make sure it has detected the word up. Not only that, it's actually got more of a more important job where it has to make sure it's robustly detecting the keyword up. So for example, if the user says up word, then the job is to make sure that the system does not accidentally trigger a false positive, as I explained before. So let's get into the code and try and understand how this is actually done. Now, the post-processing stage comes right after the inference stage. Line 162 is exactly where we had done the inference. After the inference has happened, you get the output from the neural network, the tiny conv network that we ran. What happens immediately after that is that we pass the output to process latest results. As you can see here, the process latest results function is taking the output as an argument. It's taking the current time. It's taking a reference to the found command. And if it determines that a command has indeed been found, even after it's done its robustness checks, then it will set this variable to be true. And after the command, it's going to assign it a certain score and will determine if a new command was found or if an old command, and then it would simply set it to be false. With that said, let's dig right into the process latest results and see what's actually going on here. So I'm going to do a quick search for it and bring us to the recognized command.cpp file. And you can see that the output tensor that we are looking at in this particular function is called latest results. The first thing happening here is that we are going to do a quick error check on the latest results tensor. We want to make sure that the output tensor is coming in from the neural network is exactly of the form that we expect it to be. In other words, it's got dimensions equal to 2, and we want to make sure that it's only got a single element in the first entry. And in the second entry, it's got to have K category count. In other words, at this point, you've got to make sure that the output that's coming out of in data 1, the number of softmax probabilities that you have there matches the exact number of categories that we are trying to label. Let me be more specific and say what is K category count. Category count is talking about the yes, no, silence, and unknown. That's 4 different categories. So the count is actually 4. And each one of these here is actually going to be telling us, if it's yes, no, silence, and so on. And so it's making sure that the output tensor has the right format, and that's of the right data type. After that, because will actually be collecting a queue of different inference records in order to get robustness, with high confidence, as I had previously explained, we're actually making sure by doing yet another round of self-checking that any new entry that's coming in is actually being put in the right order into the queue. So if that's not the case, we say that the results must be fed in increasing time order. This is a simple sanity check to make sure that all the results are new and no old results are getting pushed in, because of the order of the results, is not being maintained. So this can lead to some confusion in how we are processing the data. So we have to do this additional check. Assuming that everything is clear, the first thing we do is we store the new result that has just come in by pushing it in to the back of the queue. The next thing we want to do is make sure that we are not keeping an infinite number of prior guesses. What we are instead doing is that we are only trying to keep a limited number of entries in there. And the way we do that is by trying to restrict ourselves to about 1,000 milliseconds or so, which is what this variable has been defined to do. And so there's a certain time limit, and if old values kind of fall outside of this time limit, then they're effectively edged out by popping them out of the queue, and that's pretty simple, right? So long story short, the goal of this piece of code is to make sure we are only looking at some reasonable number of items, that is only the most recent items. After that, we want to check if we have sufficient results. If we don't have enough of a history in there, then there's no point of actually making, confident results. This is part of the robustness that this particular function is offering. In order to make sure that the prediction is going to make it robust again, against different sorts of input variables. The next thing we go into, assuming everything is good, is we want to calculate what's the score for each of the entries and compute a running average. This is effectively a way of building confidence by making sure we have done the inferences a few times. And then over that time, even within one second period, we've got some confidence to say that, yes, I'm actually looking at the right word based on what the user has spoken. And that's the average calculation that's happening over here. After we've done the average calculation, we're simply trying to find which category actually has the highest score in this list of variables that we have here. And that's being done by simply looking up the current top index based on the average scores. And we are seeing if the current average score is greater than the previous average score that was recorded. Once we find that, we are determining the current top index corresponds to a certain category label. For example, the category labels fall into the default scenario are silence, unknown, yes, no, and so forth. If I go right back to the file that I was in, which is the recognize command.cpp, the next stage is to make sure that there is some level of confidence in the command that is actually being analyzed. In other words, if this time we got a no, but recently we just got a yes, and that sort of bouncing is happening back and forth, then we don't have confidence in the results. And that's effectively what this code is trying to figure out. It's trying to see if the labels are actually coming out consistently. And if it turns out everything is good, then we will say that, yes, there is a new command that we have detected. At that point, we can happily go back to our primary function. I'm going to scroll down real quickly to where we were. We were inside this function. At this point, we've got some process data, and we've actually analyzed the history of the commands. So we should be quite confident in terms of what the command output was. And so we go into the second stage. If you remember, the second stage was the actual response stage. In the response stage, we want to trigger that LED. So let's go ahead and see what happens inside the respond to command function. The respond to command is taking a couple of different input variables, which we will look inside respond to command. So here we are inside the Arduino command responder file. And we're going to be working with LEDs as a means of actuating the system in response to a certain command. You might choose to actuate a motor or something to that effect. That's up to the application needs. And you can see here that the first thing this code actually does is actually check if the code has been previously initialized. This is only done the first time we are inside the main loop, during the steady state. This is not actually getting executed every time. The core part of this function is really in this region. If there is a new command, and if it turns out that the command is actually a yes, then we want the LED that is green in color to be set to a low value, which will turn on the LED. This is because the LEDs are active low, which turns them on. Similarly, if the keyword that was heard was no, then we want to set the red LED on, and we do that by simply writing a low. We're digital right over here. Last but not least, if the word is unknown, then we set the blue LED to low. This causes the system to actually turn on the blue LED. Finally, the last thing we have to see is if we need to turn the LED off. For example, let's say the first time you say yes, now that turns the LED on. Well, that's great. And then it stays on for a while. So what we're doing here is that if the previous command happened to be like 3 seconds ago, we turn the LED on, then we want to simply turn it off. And that's all there is to it. So at this point, you should be quite familiar with the overall structure. Pre-processing, in summary, involves making sure that we are confident about the result that is being generated, and that's being handled by this process latest results over here. And after the process latest results gives us a confidence response, then we determine what to do with that response, and here we are turning on LEDs. I hope at this point you're feeling quite comfortable with the overall structure of the code. As always, take a step back, think about the code in terms of what's the initialization step, what's the pre-processing step, what's the inference step, and finally, what's the post-processing step. And that's all there is to it.